Okay, the objective is to find the Taylor series for the function cosine half x about x equals to pi. So the function for Taylor series is already given. Now fx is equals to cosine half x. By subbing a, which is pi, into the equation, it is equals to 0. Now moving on to the first order derivative, we differentiate from fx, which was cosine half x, and it becomes negative sine half x over 2. By subbing a equals to pi, we have negative half, so on and so forth. Hence, the Taylor series for cosine half x is 0 minus half bracket x minus pi plus 0 plus 1 over 48 bracket x minus pi to the power of 3. Now we head over to Desmos. And this is the cosine half x graph. And we are supposed to type in our Taylor series obtained above and draw the graph, which is this. Now the question is, do the two graphs look exactly the same, and where do they look the same? To me, they don't exactly look the same. They only look the same like from 1.5 to 4.5. So next question is, what can you do to make the two graphs look more similar? We can further expand the Taylor series of cosine half x by adding more terms. So now let's try to add in more terms into the Taylor series to make the two graphs look more similar. So now going to the fourth order derivative, we differentiate from the previous order derivative, which was sine half x over 8, which will get cosine half x over 16. And by subbing a, which is pi, we get 0. We do the same for the further order derivatives by differentiating from the previous order derivative, which in this case for the fifth order, we differentiate from cosine half x over 16, which gives us negative sine half x over 32. And by subbing a, which is equals to pi, we get negative 1 over 32, so on and so forth. Now the Taylor series with more terms added now looks like this. Now we need to type in our new Taylor series in Desmos and draw the graph. So this is the graph. The question is, does the new graph look more similar to the graph of y equals to cosine half x? And where do they look the same? From the previous graph, it looks more similar to the cosine half x graph, and it looks the same from around -1 to 7. So what conclusion can you make about approximation of a function using Taylor series? The conclusion is, the further the Taylor series is expanded, the more similar it is to the original graph. Question: the three graphs seem to be exactly intersecting at x equals to pi. Why do you think that is the case? This is the case because the Taylor series is assigned about a point x equals to pi, which was stated in the question above. This is the end of the video.